All right, let's talk about one of the absolute cornerstones of modern Java development, the Executor Framework. If you've ever dealt with multi-threaded code, it can feel like you're walking through a minefield. So how do we handle concurrency and manage threads without, bringing our entire application crashing down? Well, that's exactly what we're going to get into.
So let's start with this single line of code. I mean, almost every single one of us has written this at some point. It looks so harmless, right? You've got a task, you wrap it in a new thread, you hit start, boom, done. But in a real, live production system under any kind of serious load, this line of code is a ticking time bomb. Let's dig into exactly why.
Okay, so here's the deal. Creating threads manually is just incredibly expensive and honestly, pretty dangerous. First off, every single thread you spin up eats a pretty big chunk of memory for its stack. Then there's the overhead, the time it takes the operating system to actually create and then tear down that thread. It all adds up and slows you down. But the real killer, the thing that will get you a call at 3 a.m., is that there's no upper limit. You get a sudden spike in traffic, and your app just keeps creating threads, hundreds, maybe thousands, until you get what's called a thread explosion. And that almost always ends with a fatal out-of-memory error. Game over.
And that idea right there is the solution. It's a total shift in mindset. We have to stop thinking about one new thread for one new task. Instead, we need to think about having a managed pool of worker threads that are just ready and waiting to pick up work. It's about moving from total chaos, unbounded creation, to a system of controlled, predictable concurrency.
And this is exactly where the Executor Framework comes into play. It's this beautiful abstraction that lets you separate the what from the how. Your code just says, hey, here's a task I need to run. You submit it, and you're done. The framework takes care of all the messy details in the background, reusing threads, queuing tasks, managing the whole lifecycle. You get to focus on your business logic, not on the plumbing of thread management.
Now, when you dive in, you're going to see two main interfaces, Executor and ExecutorService. Think of Executor as the super simple base. It just has one method, execute, which is basically fire and forget. But for any real work, you're going to be using ExecutorService. It gives you all the crucial stuff you need for production, like being able to shut the pool down cleanly, and really importantly, a submit method that gives you back a future object. That future is your ticket to getting a result back from your asynchronous task. Okay, so we know we want to use an ExecutorService. The next question is, which one? Luckily, Java gives us a really handy factory class called executors with a bunch of pre-configured options. It's all about picking the right tool for the job, so let's walk through the big ones.
First up, we've got the workhorse of the bunch, the fixed thread pool. It does exactly what it says on the tin. You tell it you want, say, 10 threads, and that's what you get. No more, no less. What's great about this one is that it's super predictable. If all your threads are busy working, any new tasks that come in just line up in a queue and wait their turn. This makes it absolutely perfect for things that have a pretty steady workload, like a typical web server. And here's a pro tip. For tasks that are heavy on CPU calculations, you usually want the number of threads to be pretty close to the number of CPU cores you have. That way you avoid wasting time with excessive context switching.
All right, next we have the cached thread pool. This one is the complete opposite of the fixed pool. It's all about being dynamic and flexible. It'll create new threads on the fly whenever it needs them. So it's designed for situations where you have a whole bunch of short, quick tasks. It's smart enough to reuse threads that just finished their work, but if every thread is busy, it has no problem just creating a new one. But, and you can see that big warning there, because it can create an unbounded number of threads, it has the exact same thread explosion problem we talked about at the beginning. Using this on a server is a classic interview trap and a recipe for disaster in production. Then we have the simplest one of all, the single thread executor. And yeah, you guessed it. This one uses just a single worker thread to get everything done.
Now you might be thinking, why on earth would I want that? Well, the killer feature here is that it gives you an absolute guarantee that your tasks will run one after the other in the exact order you submitted them. This is a lifesaver for any task that absolutely must not run at the same time as another one. Things like writing to a log file or maybe processing events in a specific sequence where order matters.
And last but not least, we have the scheduled thread pool. This one is all about time. It's designed for tasks that you need to run at some point in the future. This is your go-to for any kind of background scheduling you can think of. You can tell it, hey, run this task for me in 5 seconds, or run this cleanup job every hour on the hour. You can think of it as having a little cron system built right into your Java app. It's perfect for things like periodic health checks, pulling an external service, or running daily reports.
So we've seen the what, these different prepackaged pools, but to really master this stuff, we need to understand the how. Because behind the scenes, all of those factory methods are just creating and configuring one super powerful class, the thread pool executor. So let's pop the hood and see how this engine really works. This is the secret sauce. This is the logic that runs every single time you submit a task. First, the executor asks, do I have any of my core threads free? If the answer is yes, great, that thread gets the task. If all the core threads are busy, it asks question 2, is there room in the work queue? If yes, the task gets added to the queue to wait. But what if the queue is also full? Then it asks a third question, can I create a new temporary thread without going over my maximum pool size? If it can, it does. And only if the answer to all of those is no, core threads busy, queue full, and max threads reached, only then does it move to the final step, rejecting the task. And that queue we just mentioned? It's a hugely critical piece of this puzzle. You generally want a bounded queue, like an array blocking queue, because it has a fixed size. That forces your system to confront the reality of being overloaded. An unbounded queue, like linked blocking queue, is dangerous. It just keeps accepting tasks, growing and growing, silently hiding the fact that your system can't keep up until it finally blows up with an out-of-memory error. So that brings us to that final, drastic step in the decision flow. What happens when the system is completely overwhelmed? All threads are busy, the queue is totally full. This is where the rejection policy kicks in. Now, the default policy is called abort policy, and it just throws an exception. It fails fast, which is at least honest. The other standard ones, though, they're usually a bad idea. Discard policy just silently drops the task. Poof, gone. That's potential data loss. And discard oldest policy is even weirder. It throws away the task that's been waiting the longest to make room for the new one. It's just really unpredictable. Surely there has to be a better way.
And there is. This right here is a huge topic in senior Java interviews, and for a very good reason. It's called the caller runs policy.
This policy is absolutely brilliant. Instead of throwing an exception or just dropping the work, it does something really clever. It basically says to the thread that tried to submit the task, hey, we're totally slammed right now. You do the work yourself. This creates what's called back pressure. The thread that was busy submitting new tasks is now stuck doing the work itself, which means it can't submit any more tasks for a while. It naturally and gracefully slows down the producer to match the speed of the consumer. It creates a stable, self-regulating system.
Okay, so let's wrap this all up with a quick checklist of the big mistakes, the traps you want to avoid. First, never ever use a cached thread pool in a server application. Second, always favor bounded queues over unbounded ones. You want to know when you're overloaded. Third, and this is a common beginner mistake, always remember to shut down your executor service, or your application will never exit cleanly. And finally, don't just use those executors factory methods blindly. Understand what's happening underneath so you can tune the thread pool executor for your specific needs.
And really, that's the whole story right there. The Executor Framework gives you this wonderful, high-level abstraction that makes concurrency so much easier. But the thread pool executor is what gives you that deep, fine-grained control over your resources, how your system behaves under pressure, and how resilient it is. And getting that configuration right, well, it's not just some academic thing. It is absolutely fundamental to building robust, scalable, production-ready applications in Java.